Chale. So we are going to start our lecture from here. We are going to start our organic of A2, which is A2 organic, right? And we are going to start with the word arenes. The word arenes, right? This is the first word from where we are going to start our lecture. The word is arene, right? Arenes are actually what they are: aromatic hydrocarbons. They are actually aromatic hydrocarbons. Aromatic hydrocarbons. We know that aromatic जो word आपके पास आया है वो है aroma से. Aroma means we have specific smell of these compounds, right? Aroma, they have a smell, right? So they have a specific smell in them. That is why they are known as aromatic hydrocarbons, right? Arenes पढ़ने वाले हैं हम organic में arenes, right? So एरीन्स क्या होते हैं? एरीन्स आपके पास वो सारे कंपाउंड्स होते हैं, वो सारे कंपाउंड्स को आप एरीन बोलते हो जिसमें वी जस्ट हैव दिस स्ट्रक्चर, राइट? जिसमें आपके पास ये स्ट्रक्चर होगा वो कंपाउंड आपके पास एरीन कहलाएगा और आप उसको एरोमेटिक हाइड्रोकार्बन बोल सकते हो. ये एक्चुअली है क्या? ये आपके पास 6 कार्बन का हेक्सागन है. देखें ये 6 कार्बन है जिसका आपके पास हेक्सागन बना हुआ है और along with this we have alternate double bonds. हर एक कार्बन के बाद हमारे पास alternate double bond है. ये डबल बॉन्ड शिफ्ट होते हैं, ये यहाँ से यहाँ शिफ्ट होता है, ये यहाँ से यहाँ शिफ्ट होता है, ये यहाँ से यहाँ शिफ्ट होता है. जब ये शिफ्ट होता है तो ये बहुत तेजी से शिफ्ट होते हैं. बहुत तेजी से शिफ्ट होने की वजह से ये जो है एक जगह रुक नहीं सकते, घूमते रहते हैं इधर से उधर इधर से उधर. दैट इज व्हाई वी कंसीडर दिस टाइप ऑफ स्ट्रक्चर एज रिंग. ठीक है ना, अंदर हम रिंग सपोज कर रहे हैं उसको. So every compound that has this structure is known as arenes, right? They are known as arenes. Every structure that has this one is known as arene. And अगर सिर्फ और सिर्फ यही हो और कुछ ना हो, सिर्फ यही हो और कुछ ना हो, तो उसको फिर हम बोलते हैं बेंजीन. इस रिंग को अगर ये अकेला है तो आप इसको बोलते हो बेंजीन. लेकिन अगर ये रिंग और ये स्ट्रक्चर किसी और के साथ एडजस्ट है तो कॉमनली जर्नली आप उसको कह सकते हो ये एरोमेटिक कंपाउंड है, ये एरोमेटिक हाइड्रोकार्बन है, या ये फॉर सपोज आपके पास एरीन है. ठीक है, जर्नली आप इसका नाम ले सकते हो. अदरवाइज अकेला होगा तो बेंजीन और किसी और के साथ होगा तो अलग नाम भी हो सकते हैं. फॉर सपोज आपके पास क्या बना हुआ है, एक स्ट्रक्चर बना हुआ है, इट इज जस्ट लाइक अ स्ट्रक्चर, इस पे CH3 लगा हुआ है, तो दिस इज मिथाइल बेंजीन. सो इट इज वन ऑफ द एरीन, राइट? और सपोज आपके पास स्ट्रक्चर बना हुआ है, इस पे आपके पास OH लगा हुआ है, सो दिस इज फिनोल. दिस इज वन ऑफ द एरीन, राइट? अगर आपके पास ये स्ट्रक्चर बना हुआ है, इसमें आपके पास NH2 लगा हुआ है, तो दिस इज फिनाइल अमाइन. सो दिस इज वन ऑफ द एरीन एज वेल, राइट? सो these are all aromatic compounds. These are having their specific smell in them, and whenever compounds have this type of structure, they are known as aromatic hydrocarbons. Is that clear, everyone?
Yes, sir.
So let's start with the first one, which is actually benzene. So we are going to start our lecture with benzene. Benzene is one of the compound which is very important for A2 chemistry. बार बार ये लफ्ज आपको सुनने को मिलेगा. So फिलहाल A2 की ऑर्गेनिक हम इसी से स्टार्ट करेंगे और यही सारी फसाद की जड़ है A2 में. ठीक है ना? So what is benzene? Benzene is one of the arene. You can say that it is one of the arene, right? It's one of the arene because it has this hexagonal structure, right? And has a ring in them as well, right? What is the molecular formula of benzene? Molecular formula of benzene is actually C6H6, right? Benzene is one of the hydrocarbon, which is, you can say that aromatic hydrocarbon, and it is one of the arene as well. It contains 6 carbons and 6 hydrogens, right? Just look at over here. What is the structure of benzene? This is the skeletal formula of benzene, right? This is the skeletal formula of benzene. Or if you want to draw this in displayed formula, so it will be like this. This will be the displayed formula. Just look at over here. After every carbon, we have a double bond, right? Or alternate carbons, we have double bond. You can see this. This carbon has 3 bonds, so we just have 1 H remain over here. 1 H, 1 H, 1 H, 1 H, and the 1 H. You can see this 6 carbons and 6 hydrogens. So this is actually C6H6. Right, everyone?
Yes, sir.
So you can say that it is a regular hexagonal shape, right? This is regular hexagon. This is a regular hexagon structure, right? And has a ring inside it, because I told you that they are continuously in motion, right? The bonds, double bonds are always in the motion. They just change their places, and they cannot even stop for a second. बहुत तेज काम चल रहा होता है. That is why when you do experiment on them, you will not able to find out the double bond over there. तो इस वजह से हम उसको रिंग सपोज करते हैं. ठीक है बच्चों?
तो ये मोशन वाली बात समझ नहीं आई कि ये मोशन में ये मतलब.
मैं बता देता हूँ, दोबारा बता देता हूँ, कोई मसला नहीं. Just look at over here. First of all, if you talk about structure and angle, if you talk about structure and angle, आपने AS में पढ़ा था structure of angles. So if you talk about the structure, just look at over here. If you talk about the structure and angle, so let me tell you the thing over here. जरा मुझे बताइए, चले मैं नहीं बता रहा, आप ही बताएं मुझे. What will be the angle and what is the name of the structure over here? Tell me. When a carbon or when any element having 3 bonds or 2 bonds, right? 3 bonds over here. One is with hydrogen as well. 3 sigma bonds, right? One is pi bonds. Pi bond is not considerable for determining the shape and angle over there. So this is the carbon atom which is having 3 bond pairs. So what is the name of this shape or this structure? Jaldi say.
Triangular, planar.
Yes, you can call this as, this is trigonal planar. This is trigonal planar. The name of this structure is trigonal planar. And what about the angle over here? So what should be the angle?
120.
Yes, this will be 120. Kya baat hai? Zabardast. And what about the hybridization over here? Which type of hybridization is this? This is
SP.
This is sp2 hybridization. This is sp2 hybridization, right? Why sp2? Because we know that carbon has 6 electrons, right? So in ground state, it is 1s2, 2s2, and 2p2. But in excited state, we know that 1 electron from s orbital jump from s to p, and now the 4 electrons are free to take part in bonding, right? But right now we have just 3 sigma bonds that are taking part in the reaction as a sigma bond, right? One is pi bond, so we are not talking about the pi bond. So Z1 is contributing in a pi bond. So we just have these 3 that are participating in sigma bond. So we just have 1s and 2p that are contributing in sigma bond. So that is why this is sp2 hybridized, right, bacho, or not?
Yes, sir.
Is that clear, every one of you? Yes, everyone. Is that clear?
Yes, sir.
Okay, so let's talk about the structure again. You are not getting the things, so let's see it again. ये है कार्बन, ये है एक और कार्बन, ये आपके पास एक और कार्बन, ये कार्बन, ये कार्बन, ये कार्बन, right? They all are connected like this, right, बच्चों? Right. Then we know that each of them is connected with 1 hydrogen as well. So you can even see this, that everyone over here are attached with 1 hydrogen as well. Right or not, bacho? You can see this, that over here, every carbon, if you just focus about this carbon, just look at over here, how many bonds it has? 1, 2, 3. Every bond. Every carbon has 3 bonds. You can see over here as well. 1, 2, 3. Every carbon has 1, 2, 3. 1, 2, 3. So every carbon having 3 sigma bonds. That means over here the shape is trigonal planar and the angle is 120. And we also need to know this, that every carbon has 1 free electron as well. This electron is free right now. It is not participating in the bonding. So definitely it will be like this. 1pz is actually not taking part in bonding. So it's free. Now you can see this when they are going to be free and they are parallel to each other. They are parallel to each other. So when they are parallel to each other, so their electrons start attracting them. Their electron start attracting them, right? When their electrons starting attracting them, so they start making bonding over there, right, bacho, or not? Right? So they can bond over there. Even they can bond over there, right? इनमें इनका क्या कसूर है? ये भी तो बॉन्ड बना सकते हैं ना, जरूरी थोड़ी है कि वही वाला बनाए. इनके भी तो इलेक्ट्रॉन फ्री हैं, ये भी तो बॉन्ड बना सकते हैं, राइट? ये भी बॉन्ड बना सकते हैं, राइट? इनको किसने रोका है बॉन्ड बनाने से? दे कैन इवन बॉन्ड, राइट? ये भी बॉन्ड बना सकते हैं और इनको भी किसी ने नहीं रोका, तो ये भी बॉन्ड बना सकते हैं, डबल बॉन्ड, राइट? सो एवरीवन हैज देयर ओन इलेक्ट्रॉन जो कि पैरेलल है दूसरे वाले कार्बन से और दे आर अलाउड टू मेक बॉन्ड्स. डबल बॉन्ड बना सकते हैं, वो किसने रोका है उसको? ठीक है ना. अब जब देखें यहाँ पर ऑल्टरनेट बॉन्ड बन गए, अब ये कार्बन का क्या कसूर है? ये क्यों नहीं बना सकता? इसके पास भी तो सेम इलेक्ट्रॉन थे ना, तो ये बॉन्ड यहाँ से यहाँ शिफ्ट हो जाएगा, ठीक है ना. फिर ये वाला बॉन्ड बोलेगा भाई मैं क्यों ना बनाऊं, तो ये यहाँ शिफ्ट हो जाएगा. फिर ये वाला बोलेगा मैं क्यों ना बनाऊं, तो ये यहाँ शिफ्ट हो जाएगा. जब ये यहाँ शिफ्ट हो जाएगा तो ये बोलेंगे मैं क्यों ना बनाऊं, तो ये वापस यहाँ शिफ्ट हो जाएगा. इस तरह ये काम चलता रहेगा. इट इज कंटिन्यूअस इन मोशन. सो यू कैन से दैट ओवर हियर in this diagram, you can say that the pi bonds are actually delocalized. The pi bonds are actually delocalized. You can say that.
बना रहे हैं bonds.
ये आपके लिए, आपकी मर्जी है. मैंने आपके लिए बना दी है, आप बनाना चाहें बनाएं, ना बनाना चाहें ना बनाएं, ये तो आपके लिए है, ठीक है ना. So you need to know this. आपने ये AS में किया होगा ना पाई बॉन्ड वाला, तो ये तो वही चीज है. तो मैंने कोई एक नई चीज तो नहीं बनाई, पाई बॉन्ड ही बना के दिखाया आपको, है ना. And this pi bond is actually delocalized. जरूरी नहीं है आप इसको बनाएं, बस आपको ये बात पता होना चाहिए कि that pi bond is actually delocalized. ये जो pi bond है ये delocalized है, इसकी कोई जगह नहीं है, ये इधर से उधर भागे जा रहा है, इधर से उधर भागे जा रहा है, जिसकी वजह से we have giant overlapping. हमारे पास क्या हो रही है वहां पर? We have giant overlapping over there, right? You need to keep remember this. We have delocalized pi bonds and there is giant overlapping over there, right or not?
Yes, sir.
That's the thing that you need to keep remember, right? Now let's talk about something different. Experimentally, साइंटिस्ट ने देखा यार ये क्या मजाक चल रहा है, मतलब क्यों है ऐसा, ये कौन सा मॉलिक्यूल आ गया जो इतना इंपॉर्टेंट हो गया, इतनी सारी जगहों पर इस्तेमाल हो रहा है. लेट्स टॉक अबाउट समथिंग डिफरेंट. आपको ये बात पता होनी चाहिए पहली बात तो कि इफ यू हैव सिंगल बॉन्ड, अगर आपके पास सिंगल बॉन्ड है यानी कि कार्बन कार्बन का आपके पास सिंगल बॉन्ड है अगर, सो दे आर लॉन्गर बॉन्ड्स देन डबल बॉन्ड. अगर आपके पास डबल बॉन्ड है कार्बन कार्बन का, सो जो बॉन्ड लेंथ होती है ना, बॉन्ड लेंथ कार्बन कार्बन बॉन्ड की छोटी होती है, कार्बन कार्बन सिंगल बॉन्ड की बॉन्ड लेंथ बड़ी होती है. दे आर लॉन्गर बॉन्ड्स, राइट? दे हैव लॉन्गर बॉन्ड लेंथ्स, राइट? तो आपके पास डबल बॉन्ड छोटे होते हैं. So we have actually an experimental proof for you that the length of all bonds in carbon-carbon of benzene, if you talk about benzene, अब experiment किया गया, scientist ने experiment किया, तो उसने देखा यार कि scientist ने experiment जब किया तो उसने देखा कि सारी की सारी length जो आ रही है ना, they are all same, they are equal, right? अगर भाई यहाँ पर डबल बॉन्ड मौजूद है तो लेंथ डिफरेंट होनी चाहिए, लेंथ अलग अलग होनी चाहिए, ठीक है ना? ठीक है बच्चों?
Yes, sir.
ठीक है ना. हर क्लास का आपके पास क्या होना चाहिए? अलग अलग आपके पास होना चाहिए बॉन्ड लेंथ. अब हुआ क्या, जब साइंटिस्ट ने इसको एक्सपेरिमेंट किया तो एक्सपेरिमेंट करने के बाद क्या पता चला, एक्सपेरिमेंट करने के बाद ये पता चला कि भाई ये तो सारे एक जैसे हैं, जितने बॉन्ड आए हैं एक्सपेरिमेंट के रिजल्ट में वो सारों की लेंथ एक जैसी है। तो इसका मतलब ये हुआ कि जो बॉन्ड आपके पास डबल बॉन्ड है वो तो चेक ही नहीं हुआ, वो तो आया ही नहीं एक्सपेरिमेंट में, लेकिन प्रॉपर्टीज ये दे रहा है। एल्कीन वाली भी बहुत सारी जगहों पर ये प्रॉपर्टीज एल्कीन वाला देता है, बहुत सारी जगहों पर ये एल्केन वाली प्रॉपर्टीज दे रहा है, ठीक है ना। तो बहुत सारी चीजें देखी गई, उसके बाद इस बात का आइडिया लगाया गया कि वी स्टिल हैव pi bonds over there, but pi bonds are alternate pi bonds over there, and they are not going to be analyzed by experiment because they are continuously in motion, right? They are just overlapping, giant overlapping over there. The pi bond is actually delocalized. It is not going to stay at one place. It is continuously in motion, right? That is why the motion is too quick. That is why they are not even analyzing by the method, right?
Yes, sir.
So this is what the structure of benzene that you need to keep remember, right? Then we have a lot of arenes over there in the structure. We need to know about these arenes. For example, if you need to know about arenes, so we have a lot of type of arenes. Arenes are when you have a carbon hexagonal planar and a ring over there. This is one of the main thing of arene you need to keep remember. ये जिसमें है वो arene, right? So this is also one of the type of arene. इसका नाम क्या है? Naphthalene. This is naphthalene. We have one more thing over here. This type of. This is also one of the arene. जिसका नाम है anthracene. इसका नाम है anthracene. Then we have one more which is like this. इसका नाम है बच्चों pyrene. We have a lot of molecules like जिसका अलग अलग नाम हो सकते हैं, ठीक है बच्चों?
Yes, sir.
Yes, everyone, is that clear? Yes or not?
Yes, sir. Sure.
We have few more examples of arenes, the compound having benzene ring, right? So one of the compound is like I told you earlier. For example, if you have OH over here, so this is one of the compound known as phenol, right? For suppose if you have NO2 over here, so this will be known as nitrobenzene, which is more important in our syllabus. We need to discuss them, right? For example, chlorine is over there, so this is known as chlorobenzene. This is also one of the things that we need to consider in our syllabus. We have one more type of thing that we need to discuss and need to know. This is methylbenzene. This is also one of the arene, right? This one we need to discuss in our syllabus also. This is phenylamine. This is the part of our syllabus. So these are all the compounds that we need to keep remember, that we need to keep in practice, right? Or this is one of more, so this will look better, more organized. Or suppose if I write this one, so this will be benzaldehyde. Right. So these are some examples that you need to keep remember about arenes. Right. One more thing that you need to know is actually isomerism. Even these structures show isomerism, right? So if you talk about isomers, so it can be termed or it can be classified as isomers. Just look at over here. For suppose we have chlorine over here, right? And we have chlorine over here. For suppose we have one more possibility to put chlorine. For suppose this will be here and here. For suppose chlorine will be over here and over here. So they can be termed as isomers. if you consider this one the first carbon, so this will be the second one. So you can say that, so this will be 1,2 dichlorobenzene, and then this will be 1, 2, 3, 4. So this will be 1,4 dichlorobenzene. And if you talk about this one as a first one, so it will be 1,3 dichlorobenzene. Okay, बच्चों. Clear, बच्चों?
Yes, sir.
So these are actually isomers. These are actually isomers that you can even consider as an isomer, right, बच्चों? So the change in placement can even tell you the isomerism in this syllabus as well. So just write it down first, then we are going to talk about the next things, right? So we have some physical properties of this as well. Let's talk about physical property. Now we are actually talking about physical properties of benzene, right? We're just going to end arenes now. We are going to talk about benzene now, right? So physical properties of benzene. अब हम ऑफिशियली स्टार्ट कर रहे हैं द टॉपिक बेंजीन और हम उसकी बात कर रहे हैं उसकी कुछ फिजिकल प्रॉपर्टीज की. लेट्स सी सम फिजिकल प्रॉपर्टीज ऑफ बेंजीन. Number 1, benzene is actually liquid at room temperature and pressure. Benzene is actually liquid at room temperature and pressure, right? Why? Because we know that here we have low van der Waals forces or induced dipoles, because there is no difference of electronegativities when we talk about the difference of electronegativity between the bond of carbon and hydrogen. So definitely there is very less or almost negligible difference of electronegativities. That is why there will be no partial positive and no partial negative over there, and they don't have partial charges, they don't have permanent dipole, right? So they have induced dipole right now, and the induced dipole are weak, so that is why they are liquid at room temperature and pressure. Then they are aromatic compounds, so they have strong smell, right? So it may be pleasant and it may be unpleasant as well, right? Then we know that they all have carbon and hydrogens, so they are non-polar in nature, right? They are non-polar in nature, and the one which is non-polar definitely insoluble in water, like oils. Oils are not going to be soluble in water because they are non-polar, and water is actually polar. So that's why they are insoluble in water, but soluble in organic solvents, but soluble in cyclohexane. This is one of the organic solvent, right? Then definitely they are not a conductor of electricity because they don't have ions, right? They are not a conductor of electricity. They are even having low melting and boiling point. They have low densities, and these are the things, right, Bacho?
Yes, sir.
So these are the physical properties that you need to keep remember. Then if you talk about reactivity, so this is one of the very important thing that you need to keep remember. Reactivity. The reactivity of benzene is very important to know, right? First of all, you need to remember that benzene attract electrophiles same as alkenes do, right? You need to keep remember the very first point over here. The first point is benzene attracts, right? It attracts electrophiles. It attracts electrophiles as alkene do, right? As alkene do. You need to keep remember, like alkenes, benzene are also going to attract what? Electrophiles. And what are electrophiles? We know that they are the species that have deficiency of electrons. You can say that deficient of lone pair, right? The species that has deficient of lone pair is known as electrophile. Or agar ye positive ho to sone ka suhaga hai, then it will be a good electrophile, right, bacho?
Yes, sir.
Now, why benzene is doing this? What is the reason behind this? Why benzene is going to attack on what the substance which is electrophile? So you need to keep remember because extra stability, because of extra stability due to delocalized electrons, right? Due to the delocalized electron, we know that they have delocalized pi bond, no? So that is why it is going to attack on what? Alkenes, right? But so because of extra stability, because of extra stability due to delocalized electrons. Delocalized pi bond bhi aap bol sakte hain, so that's not a big deal. You can use this word as well, right? Then if you remember the last one in AS, the alkene are going to react with HBr, HCl, Br2, H2O, H2. In all these cases, they are going to add over there. They are going to add over there. HBr is going to add into C2H4, going to give you halogenoalkane C2H5Br. And same as it is, if H2O is going to add over there, so it will giving you C2H5OH, will be alcohol. They all are electrophilic addition reactions, right? So over here, if they are going to be working as alkenes, so definitely they need to react with HBr and Br2 as well, right? Just for suppose, if you talk about C2H4, if it is reacting with HBr and forming what? The double bond is going to break, and it is forming what? One carbon having H and one carbon having Br. So it will be C2H5Br, right? This is a simple electrophilic addition reaction which alkenes do, right? But when you talk about benzene, so it also has double bond, right? Alternate double bond. So it should react with HBr because it is also want to attack on what? Electrophile. So it is going to attack on hydrogen and forming one over here H and one over here Br. Should be like this, right? But there is no reaction. That means somewhere benzene is somewhere very similar to alkene, but not going to follow the chemical properties of alkenes, right? Even it can not attack on bromine as well, right? वो attack नहीं करेगा bromine पे भी. If you want that the bromine is going to react with benzene, so we need to do something, right? Same as it is if you talk about bromine water and aqueous acids, they don't have effect on benzene, right? For suppose if you talk about C2H4, right, you are adding bromine at room temperature over here, you will see that over here the bromine is going to attach with this and it is going to be decolorized. You can say that reddish brown color of bromine, decolorized. We know that we have pi bond over there, double bond over there, is going to be decolorized. But if you talk about benzene, so if you have benzene and you're adding bromine over there at room temperature, there is no effect, not at all, right? Same other, there is no effect of aqueous acids over there as well. So you need to keep remember what is this. चल क्या रहा है भाई? अगर डबल बॉन्ड है और ठीक है आपके पास, आप इलेक्ट्रोफाइल पे अटैक करते हो, तो फिर क्यों नहीं अटैक कर रहे हो एल्कीन्स की तरह? जो एल्कीन्स केमिकल प्रॉपर्टी शो कर रहे हैं आप भी करें, नहीं करते. They are something different. That is why they are special to study, right? So if you want कि bromine react हो, if you want bromine react हो बेंजीन के साथ, तो उसके लिए आपको ब्रोमीन को इलेक्ट्रोफाइल बनाना पड़ेगा, खुद बनाना पड़ेगा. ऐसा नहीं है कि अटैक करे और फिर कुछ इस तरह होता है. आपको पहले इसको स्ट्रॉन्ग इलेक्ट्रोफाइल बनाना पड़ेगा, उसके बाद जाकर बेंजीन उस पर अटैक कर सकता है. So what we need to do, first of all, if you have bromine Br2, so you need to do some extra efforts for this. You need to break the bond hydrolytically between bromine to bromine, and you need to make one bromine positive and one bromine negative. You know that this negative is due to the both electrons received by this bromine, that is why it is negative, and the electron donated by bromine, that is why it is positive. Now, this is actually what electrophile. This is not stable naturally. You cannot find this one naturally. So you need to work on this. You need to make it artificial, right? Once you make this, now this is actually strong electrophile. Now benzene can do something for this, right? Talk about benzene, and you just find out bromine near to this. Now benzene attack on this bromine. Now benzene कहेगा ले भाई मेरा इलेक्ट्रॉन ले ले, आप आजा मेरे पास आ, ठीक है ना? तो अब उसको बोलेगा आजा। ये कौन सा गाना याद दिला दिया, आज बहुत वायरल चल रहा है ये। और यहाँ से आपके पास ब्रेक हो जाएगा डबल बॉन्ड, और यहाँ पर ब्रोमीन हाइड्रोजन के साथ अटैच हो जाएगा। और जाहिर सी बात है, ये हाइड्रोजन के साथ अटैच हो गया तो प्रॉब्लम ये है कि ये इसको उठा के यहाँ भेज देगा, फिर ये भेज देगा, यहाँ भेज देगा, यहाँ भेज देगा, यहाँ भेज देगा। हर कार्बन के 5 बॉन्ड तो नहीं बन सकते ना। अभी आप देखें, अगर यहाँ डबल बॉन्ड होता तो इस कार्बन के 5 बॉन्ड हो जाते, तो डबल बॉन्ड इसलिए यहाँ से टूट गया, बाकियों के 4 हैं। सेम ऑलरेडी जैसे आपके पाई बॉन्ड डीलोकेलाइज है, इसी तरह ये हाइड्रोजन भी चारों तरफ घूमेगा, लेकिन कोई इसको अपने पास नहीं रखेगा। हर कोई ये कहेगा कि मुझे तो डबल बॉन्ड ही चाहिए, मुझे आप चाहिए ही नहीं, ठीक है ना? तो एंड में क्या होगा, ये डबल बॉन्ड वापस यहाँ बन जाएगा और ये हाइड्रोजन को बाइज्जत यहाँ से निकलना पड़ेगा। और जब ये यहाँ से निकल जाएगा तो आपके पास हाइड्रोजन की जगह पर एक्चुअली ब्रोमीन आ गया, और हाइड्रोजन जो है साहब यहाँ से बाहर निकल गए, ठीक है ना? तो दिस इज एक्चुअली इलेक्ट्रोफिलिक रिएक्शन because the attack of benzene on electrophile, but right now this is not addition because hydrogen is going to be replaced. So this is substitution. अगर आपके पास होता क्या, अगर आपके पास होता alkene, so we know that alkene में आपके पास क्या होता, आपके पास HBr होता, आपके पास क्या होता, या HBr नहीं, हम ब्रोमीन ही रख लेते हैं। और सपोज आपके पास ब्रोमीन होता तो ये पार्शियल नेगेटिव एंड पार्शियल पॉजिटिव होता, कार्बन इस पर अटैक करता है, ये इस पर अटैक करता, अगले स्टेज में आपके पास यहाँ ब्रोमीन अटैच होता, ये पॉजिटिव होता, ये हाइड्रोजन 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 हाइड्रोजन, राइट? फिर अगले स्टेप में ब्रोमीन नेगेटिव वाला इस पर अटैक करता, और फिर क्या होता, आपके पास दोनों ही कार्बन पर ब्रोमीन अटैच हो जाता। दिस इज इलेक्ट्रोफिलिक, बोथ आर इलेक्ट्रोफिलिक, बोथ आर इलेक्ट्रोफिलिक रिएक्शंस। दिस इज also electrophilic, and this is also electrophilic. Both are electrophilic because electrophile is over there. The attack is on. Attack on electrophile is on, right? But right now this is electrophilic and the reaction is substitution. So this is electrophilic substitution and this one is electrophilic addition. Am I clear about you?
ब्रोमीन को हमने पहले इलेक्ट्रोफाइल बनाया, फिर रिएक्ट करवाया, यहाँ तक समझ आया। फिर ये रिएक्ट कैसे हुआ, हाइड्रोजन 6 निकलने चाहिए ना कार्बन 6 से, तो
क्या चीज?